Okay, so what we're going to do today is basically go over the four theorems that we've talked about thus far in order to solve different types of application problems. So what I want you guys to start with doing is actually we're going to turn to page 108 and talk about the four different theorems that we can use in order to solve problems so that we all have them in the same place. Okay, so remember when you're doing triangle proportionality theorem, remember that means that these two segments are parallel to each other, which in turn, due to angle, here and here, from these two triangles sharing this triangle and this triangle, they both share this top angle, so that's one of their congruent angle pairs for angle. And then these, or doesn't matter, you could also use the other side for your second angle because of corresponding angles from lines, parallel lines cut by a transversal. Anyway, with that all being said, remember if you're going to do this, you have two options. You can do like if this is A, this is B, this is C, and this is D. You can do part over part equals part over part. So A over B equals C over D. Remember, you can also look at it as a whole. So one of your parts over the whole, so add those two together, equals the other part over the whole. So it doesn't matter how you look at it, this way or this way. You're either doing part over part equals part over part, or part over whole equals part over whole, depending on how the problem is set up and what's best for that. The next one is the angle bisector theorem. So remember that says if these two angles right here are congruent, then let's call this A, let's call this B, let's call this C, and let's call this D. Then you can go across and then same side of the triangle. So A over B equals, go across, C over D. Okay. Angle, we just point out because a lot of people, that's probably the most common one, but remember you also have side similarity that you can use, and you also have side similarity. Okay, remember that angle needs to be included in the middle. So there isn't much to write down here. There isn't a formula, but if you have any of these, then you can set up your proportions based on your similar side. Okay, and then the last one is the geometric mean. So remember there's two of those. That's either your altitude equals left times right. So altitude squared equals left times right. Or if you're given the leg, remember it could be leg squared equals short times long, which is your hypotenuse. So it could be leg squared equals short adjacent times long, or the hypotenuse. It doesn't matter how you think about it. Just make sure that it's the whole thing. So based on those four, we're going to use those in order to solve the problems today. We just have a couple examples to go through. And the biggest thing is just identifying what you know about the picture and what theorem you can use. So if you look at page 109, we have a meter stick that casts a shadow 65 centimeters long. At the same time, a tree casts a shadow 2.6 meters long. How tall is the tree? So you guys, you want to remember a couple things here. Remember, shadows are always going to be on the ground for the purposes of these problems. Obviously, we know they can be on a wall and blah, blah, blah. Just, they're on the ground, okay? Stop fighting it. So your meter stick is right here, and it casts a shadow 65 meters long, okay? And remember, we make that a right angle. Now, this is 1 meter because it's a meter stick, okay? And then it says at the same time a tree, so you have a tree that casts a shadow 2.6 meters long. Remember, for the purposes of us, our trees are always right angles. And they want to know how tall the tree is, so they're looking for that. Okay. Now, a couple things. It says determine if the triangles are similar. Well, we know we have the right angle, and we talked about this a while ago. So you can look at this one of two ways. These are always done at the same time of day. So that means either you can look at this to get the triangles to be similar, that the angle of elevation, so this angle going up to the sun, is going to be congruent to this angle, because when you're looking up to the sun, if it's the same time of day, that'll be the same. Or you can say that the top angles are going to be congruent because it's the angle looking down from the sun, but it's more logical for us to use the bottom angles. So now we know the triangles are similar by angle, okay, which is all written out here. So the rays of the sun create the shadows, and so shadows are going to be parallel, they're on the ground, and then your right angles are formed with the ground, so therefore we have angles. So that's kind of what I just went through. So it says solve the problem. However, one thing I messed up. This is centimeters, I'm sorry, and this is meters. So we have meters, we have centimeters, we have X, and we have meters. So it doesn't say which one you're going to have to solve in. So if I have 2 in meters and 1 in centimeters, I'm going to take this 65 centimeters and I'm going to convert it. Well, 65 centimeters means we're looking at 0.65 meters. Okay. So, because we have 100 centimeters for every 1 meter, so that's just converting it all to the same unit. So now we can say, okay, well, to solve the problem, we can do 1 meter over 0.65 equals X over 2.6. So you can set it up that way, or remember, you can also do 1 over X and do vertical over vertical over vertical equals horizontal over horizontal. Just make sure that you, in this first case, you have the same triangle here. In the second case, you have the same triangle here. Make sure that that's one of your options. You don't want the same triangle measurements to be on the diagonal. Okay, so no matter which way you set it up, when you cross multiply, you get 2.6 equals 0.65x. And when you divide, you should end up getting an even 4. So you get X equals 4, and that's in meters. So that's how tall the tree is. And that's your answer. Okay. On the next page, for example number 2, example number 2 says finding the distance across a canyon can often be difficult. A drawing of similar triangles can be used to make this task easier. Use the diagram to determine AR, which they've already marked for us as the distance across the canyon. So they're trying to figure out what that distance is. So if you notice, they've already measured a couple things. Okay. And they're saying that it's a drawing of similar triangles. So if you look at this, right now it looks like you only have one angle pair. So I would say, oh, well, you can't really use, similar triangles, but you don't need to look for another angle pair because they tell you right off the bat, yes, they're similar, so you can just go with it. So now you just need to make sure you set it up correctly. So AR is the same. It's across from your vertical angle, so then that's going to go with 75, and then the 180 and the 90 are a pair. So when you set up your proportion, you have X over 75 equals 180 over 90. And then when you cross multiply, you get 90x equals 13,500. And when you solve, you get 150, and that is in meters. All right, for example number 3, it says, to find the distance across a pond, Rita climbs a 30-foot observation tower on the shore of the pond and locates points A and B so that AC is perpendicular to CB. Okay, so that's all. They already drew the picture for us. So she goes 30 feet up in the air, and then she is standing here, and it says she locates points A and B so that AC is perpendicular to CB, so that's why you have the right angle right here. It says she then finds the measure of DB to be 12 feet, so that's this right here. What's the measure of AD, which is the actual distance across the pond? So you're assuming that this is the distance across the pond. So if you look, we have an altitude here. So we can use our formula of altitude squared equals left times right. So we're going to get 30 squared equals X times 12. So we end up with 900 equals 12X. And when you divide both sides by 12, you get 75 for X. So the distance across the pond is going to be 75 feet. And then for the last one, all right, for example number 4, excuse me, It says to estimate the height of an overhang, a surveyor positions herself so that her line of sight to the top of the overhang and her line of sight to the bottom of the overhang form a right angle. So she's sitting right here at point C, okay, and the overhang is from B to A. It says, what is the height of the overhang to the nearest tenth of a meter? So they don't give us these numbers in the problem, but obviously we can use them because they're in the picture. So she's obviously 8.5 meters from the overhang. That's our altitude. And then they've measured from where she went to the bottom of the overhang is 1.75. We need to find this so that we can find the whole distance. So this is very similar to the last problem because it's an altitude. So on that one, we do the same thing. Altitude squared equals left times right. So in this case, you're going to do the same thing, except it's just your left and right are flipped. It's going to be kind of up and down since they rotated the triangle. So you end up with 8.5 squared equals left times 1.75, which is your right. So we end up with 72.25 equals 1.75x. Divide both sides by 1.75. And it's not pretty, but round it to 2 decimal places correctly, and you get 41.29 meters for x. But let's see, they're asking for to estimate the height of the overhang. You want to pay attention to this. Her line of sight to the top of the overhang and to the bottom of the overhang. That means this is the top of the overhang and this is the bottom. So you don't want just to end with the 4.29. You want to add them together. So the actual height is going to be 4.129 plus the 1.75. I'm sorry, 41.29 plus the 1.75. So you get 43.04 meters is the total height of the overhang. Okay. So your homework tonight is simply just using those theorems to go through and answer any questions that are given to you. And the nice thing is in the book, they have a lot of the pictures drawn for you and labeled. And they're a lot like the ones we just did. So you have the rest of the class period to work on that homework.